Hello and welcome to another one of D's ADD videos. Today we're going to look at KC calculation with values for products as well as the reactants initially. So because we're not at equilibrium, what we need to do is figure out Q to figure out which way the reaction is going to proceed to get to equilibrium. Once we do that, that tells us what the sign of our change is going to be. So in this case, Q is going to be concentration, the reaction quotient is the concentration of the products over the reactants. When it's at equilibrium, that's when we get this Kc value. So here we have 0.1 times 0.1, which becomes 0.1 squared, over 0.6 times 0.6, which is 0.6 squared, which gives you a Q value of 2.78. And when you compare that to your Kc, you see that you're less than the 4.06 value. So if you remember the concept video that I drew the potential energy diagram, Q has maximal potential energies where Kc is a minimal value. And we were at this point where Q was less than Kc. So to go to equilibrium, the reaction must proceed to the right. Okay, so what that tells you is if it's proceeding to the right, that means we're taking away from here and we're adding to here. Had Q been greater than Kc, these signs would be opposite. Okay? And then it's allowed to go to equilibrium. So it would be 0.6 minus x, 0.6 minus x, 0.1 minus x, 0.1 minus x, and then you're going to have and when you plug into the Kc equation, and two like bases being multiplied, you add the exponents 1 plus 1, there's understood 1 to be there, both of those, you get that, and that equals that. Now to get rid of the square, you square root both sides, and when you do that, you're going to get .01, and wait a second, did I do this backwards? Did I do products, reactants over? I sure did reactants over products. I apologize, let me fix that. Hopefully some of y'all were panicking, going, why is this not working? I thought I understood it. Sorry about that. Those of you that caught on, good, you're paying attention, not just blindly copying like so many people do nowadays. Try to understand what you're writing down before you write it down. Don't just blindly write it down. Let's see, what else did I mess up on? Yes, this is a plus sign. Full of mistakes, it seems like. Sorry about that, guys. At least I caught them right. Then you cross multiply, and then you're going to distribute this 2.01 to the 0.1 plus x, and you're going to get 0.1 plus x equals get all the x's on one side by adding the 2.01 on both sides, and subtract the minus 0.1 on both sides. You're going to get 3.01 equals 0.021. Forgot the x there. And then x as a result can be solved for 0.007. This is the change that we were looking for. Alright, so now we can calculate the equilibrium concentrations by plugging that change in way back up here. So that would be 0.6 minus 0.007 for both of those, which gives you equilibrium concentration for the reactants of 1.053 molar. And this one is going to be 1.07 or 0.107 molar for both of those. Alright, let's recap. We were given initial conditions for this reaction, and we had to calculate Q. We found out Q was less than Kc, so it had to go to the right. Because it's going to the right, that made this sign negative, and it was increasing over here. Had it been the other way around, these would be negative here, and those would be positive here, but it wasn't, so we went on, we plugged into the right Kc values and concentration values, square root, and then a little algebra later gets you your change. Don't forget to plug your change back in. Just because you got X, a lot of people are like, yeah, I'm done. No, they wanted concentrations at equilibrium. So you plug into this right here in blue to get those orange answers there. Alright? Hope this has clarified things a little bit. Make sure you practice. Thank you and have a nice day.